is asking for the maximum speed at which electrons are ejected, gives us wavelength of 95 nanometers, and work function of 5.9 electron volts. Convert the nanometers to meters, which you get 9.5 times 10 to the negative 8th, and convert electron volts to joules, and you get 9.44 times 10 to the negative 19th. The function for kinetic energy is 1/2 mv squared, so we're going to use that to find velocity. And we get use the functions E equals hf, c equals wavelength times frequency, and frequency equals c over wavelength. And we can replace the f in this function with this, so we end up with E equals h times c over wavelength. So we start off with this function, E equals ke plus w, and then replace E with this, and plug everything in. So Planck's constant, speed of light, wavelength, which is wavelength, this, 9.5 e negative 8 meters, so, and equals ke plus 9.44 e negative 19 joules. 1.14, this ends up to be 1.146 e negative 18 joules. It equals ke, and you replace ke with 1/2 mv squared, so this 1.146 e negative 18 joules equals 1/2 mv squared. Replace m with the mass given top, and you divide by 1/2 and the mass, square root it, and you get 1.6 e negative 6, or e 6 meters per second is the maximum velocity. 8 is asking for A, the maximum kinetic energy, and B, the range of wavelengths. So for 8, given is the wavelengths range from 890 nanometers to 750 nanometers, and work function is 2.28 eV. You convert eV to 3.65 e negative 19 joules, and again use these functions to get E equals h times c over wavelength. Alright, start with this and replace it with h times c over wavelength equals ke plus w. Plug everything in. So wavelength, we're gonna start with the 380 nanometers because it's the maximum kinetic energy, so smaller wavelength has a higher kinetic energy. Plug everything in, work function from here into here, and solve for ke. You get 1.58 times 10 to the negative 19th joules. Then for the second part, B, it's looking for the range of wavelengths. So you look for the wavelengths, solve for wavelengths. E equals h times speed of light over wavelengths. Plug everything in. So E, you plug in 3.65 e negative 19. You plug in Planck's constant, speed of light. You solve for wavelength, and you convert it to nanometers, and 380 nanometers is a minimum, and it goes up to 4.5 nanometers.